Hello wonderful person, this is Anton, and in today's video I wanted to answer a simple question. Can we actually terraform this beautiful planet known as Venus using a very unusual technique where we cover the sun? Let's find out using Universe Sandbox Square. Welcome to What the Math. So you may already know that Venus is actually the hottest planet in our solar system. Its temperatures are ridiculous, usually around 473 or higher degrees Celsius. That is a very hot planet. Nothing really would survive here for a very long time, even if it was encased in metal and protective layers. As a matter of fact, all of these satellites we've sent to Venus survived for just like 1 or 2 hours before completely melting and disintegrating. Also because the surface pressure here is relatively high, and because the atmosphere of Venus contains quite a lot of hazardous materials and acids. But nevertheless, there's still possibly a way for us to terraform this. Now, I've done this previously in one of the videos I posted last year, but I'm sure there's so many other ways we could do it using smart techniques. And here, I wanted to talk about two concepts. One of these concepts is going to be the Lagrange points. And this is related to something you see on the screen, the point between Venus and the Sun, where we can actually place an object that will orbit directly between them relatively indefinitely, with some minor corrections once in a while. There's quite a lot of objects we have in our Lagrange points around Earth. As a matter of fact, one of the most famous satellites that takes a lot of really cool pictures of our planet Earth, like you see right here on the screen right now, is actually from a satellite that is located at the Lagrange point between Earth and Sun. So we could maybe place something right there. And why would we do that, you may ask? Well, this is of course to hide the Sun from Venus. So what we're going to do is we're going to try to lower the temperature of this beautiful planet and thus start the terraforming process. And to lower the temperature, we're going to basically create a very large shadow around the planet. And let's see if this works. Or at least if we basically cheat a little bit and lower the luminosity of the sun. And to test how much sunlight Venus is going to be getting, we're going to look at the value of radiative power under temperature. So we want to decrease this dramatically by, like, I don't know, something like at least 70%, maybe 80% of this value. And we'll see what happens. So I believe that unfortunately, if I were to place an object here that would create a shadow, like for example, if I were to place the moon here, that would possibly create a shadow. I don't believe that it will actually reduce the radiative power. So let's just try this. Okay, so it totally did something that I didn't expect. It unfortunately melted Venus due to the tidal effect bug. That's not what I expected. So let's try this again by placing the moons a little bit farther and see if this in any way affects the radiative power that Venus receives from the sun. And so every time the moon passes and leaves the shadow, I don't think anything happens, unfortunately. So this suggests, oh, I did it again by accident. So this suggests that unfortunately placing an actual object at the Lagrange point, which I believe would be somewhere around here, maybe. Somewhere around right there. So placing an object in the Lagrange point here would not really change the temperature in the game. So we need to improvise here and do a bit of a role playing, pretending that the object that we actually placed in the Lagrange point is going to lower the amount of sunlight or amount of radiative power that Venus receives. So we're going to cheat a little bit and basically focus on decreasing the luminosity of our sun. Let's start this. So imagine that in the future we'll launch a very large satellite-like structure that can unfold and create a very large shadow that will cover Venus. So this would be an object possibly thousands of kilometers across, maybe very thin, and we could also use that object to possibly even convert some of the solar energy into some kind of a power that could then be transferred back to Earth. So this would serve a twofold kind of function. One is to create a lot of energy, and energy that we can use on Earth or even in the interplanetary space. Maybe this could be used as some kind of a refueling station for the spacecraft, that basically will be flying to other planets. But what Venus will receive from that is a very large shadow that will reduce the radiative power. So we're aiming at the temperature of about, let's just say 30 degrees Celsius. Let's see how much radiative power we have to lose in order for us to actually get there. So in other words, by how much does the luminosity of the sun has to change in order for Venus to become habitable? We're going to start with halving it. We basically are going to take this and divide it by 2. And doing so reduced the radiative power and the temperature by over 100 degrees Celsius. So that means that if we were to cover a relatively large proportion of Venus, the temperature would reduce dramatically, but is still not really at the point where we can actually terraform the planet. So let's find out what we need to do here for us to actually get Venus to the point where it's much, much colder. Let's basically reduce this by about 5 times of the original value, basically reducing the luminosity or the amount of sunlight Venus receives by about 80%. And here we go. Temperature is decreasing, radiative power has decreased as well, but we're still a little bit too hot. Looks like even 80% is not enough. Alright, let's go into something a little bit more dramatic. Let's reduce this by 20 times. We're going to go into 95%. And at about 20%, sorry, not 20%, about 20 time reduction of sunlight, we're slowly getting to the point where it might actually reach the temperature of water vaporization, or maybe even lower. Oh, look at that. It's actually dropping quite dramatically. So let's see how low we will get here when we reduce the amount of sunlight that Venus receives by about 20 times. And at 20 time reduction of luminosity, we've reached a point of about 83 degrees Celsius. Still a little bit warm, but this is when we might actually start seeing liquid water, if there was any water on the surface of Venus. So that's a good start, or I guess that's a good continuation. Maybe let's reduce this a little bit more. This would be something like about 97% reduction of the original value. So we only receive about 3% of sunlight now. And just like that, the temperature suddenly dropped to about manageable 30 degrees Celsius. Excellent. So we're gonna stop here actually. We're gonna stop at this temperature. And so this is essentially assuming that there's a very large sail-like structure or some kind of a big, large cover that only allows about 3% of the starlight to reach Venus from the sun. Now, this actually creates 2 really excellent opportunities. One is we can now reintroduce water to Venus because one of the reasons Venus lost its water is because it was basically irradiated by so much sun, and without magnetosphere, it was unfortunately bombarded with starlight that stripped it of its water and created the runaway greenhouse effect. On the other hand, having so little starlight will also allow humans to easily walk on the surface of the planet or even live in a space station around the planet without worrying too much about very dangerous radiation that might be coming from the sun. And so here we've actually reached a really nice point of 32 degrees with a very large cover somewhere in front of the sun. Unfortunately, we can't really create this in the game because there is no such object available to us. Now, what's next? So we have the temperature under control. We now need to introduce some water. How do we do that? Well, we're going to go into the asteroid belt between Mars and Jupiter, and we're going to redirect certain asteroids that will have been found to contain quite a lot of water, and we're going to bring them to Venus. So let's just say we actually found a few asteroids that we can redirect and collide them with Venus. Now, we might actually have to bring either very large ones here or quite a lot of smaller ones, just so we can actually increase the levels of water and bring all of it to the surface of Venus. We might also need to bring some kind of a bacteria. Okay, so there we go. It's about 0.00003% of mass, so that's definitely not enough. we might also need to bring some bacteria to do a few things. One of those things is we need to start capturing some of the CO2 and putting it back into the actual grounds of Venus, or maybe create some kind of an interesting fuel or something else that will basically reduce the amount of carbon dioxide, but most importantly, various acids, specifically sulfuric acid, that is actually everywhere in the atmosphere of Venus. So even though the actual atmospheric pressure is not a big deal for us, the presence of sulfuric acid and other acids might actually be not very beneficial to our health. It will most likely kill us instantly. We also need to bring oxygen, of course. So by bringing various bacteria that can actually do that for us, possibly genetically modified bacteria, we can start changing the atmosphere, maybe reducing the atmospheric pressure just a little bit, and rebalancing everything, and creating something that is a lot more accommodating to humans, with quite a high content of oxygen, quite a lot of water, and quite a lot of other elements that might be beneficial to us. Now, there's quite a lot of things we're still missing for this to be a perfectly terraformed world. Like, for example, we still might not have enough nitrogen to make this a good atmosphere for us, because our atmosphere is pretty much like 75% nitrogen. And we also need to bring the atmospheric pressure down simply because we actually want to have the content of various toxic materials down and basically remove it completely from the atmosphere. So this might take quite a lot of work, but using genetically modified bacteria, I'm pretty sure we can definitely do it. So when we actually terraform this world, and let me just show you what the surface of Venus looks like now, we'll most likely have some water on the surface. It will be relatively manageable and not so dry anymore. We'll have clouds in the sky. The pressure will be still quite high, but it will be required for the first few thousands and maybe millions of years, simply because if we actually reduce the surface pressure here, the sail or the cover that's basically covering the sunlight will unfortunately create way too much shadow, and this planet will freeze. So we need to maintain the pressure just so that it's actually able to maintain a very comfortable surface temperature for humans to survive. And I think I've actually achieved that by reducing the surface pressure to about 71, and I think that's about it. And here we go. So there's your terraformed Venus, using a technique that's a little bit unusual, but is totally possible scientifically. Essentially, placing a very large object, a huge object, that is going to be placed in the Lagrange point between the Sun and Venus, right about there. And here I'm using this monolith object that we have available in the game, and basically making sure that this is a humongous sail-like structure, or in this case, it's just a monolith that seems to be reflecting everything, that will cover Venus from the Sun, and will allow it to receive a lot less sunlight than it would receive otherwise. And so, if we could do that one day in the future, if we could create a material that's able to absorb the starlight and maybe reuse it for some kind of a energy field or energy that we'll need to power up our spaceships that will land here for refueling, we could then maybe terraform Venus using this relatively simple technique. And so that's essentially all I wanted to talk about in this video. So this is another terraforming technique for the future. If you're watching this in the future and you're trying to decide how to do it, maybe that will work. Anyway, come back tomorrow to watch something else and learn something completely different, because this channel is all about education through video games. I'll see you guys tomorrow. Please subscribe if you still haven't, and share this video with someone who might enjoy watching educational videos. I'll see you later. Space out. Game you later. And as always, bye bye.